we'll deal with it. So frustrating though. Okay. Intro to vertical motion. My poorly done handwriting. Okay, so this is like the first talk we had in class. If you're trying to remember what class this is, do I need to say anything more than skydiving? I think that basically tells you everything about what you missed. What we're going to be talking about here is just some basic ideas you need to remember when you're looking at the world of vertical motion, okay? The first thing that you need to remember with vertical motion, as these dots keep appearing, is that if you are at your maximum height, okay? If you're at max height, and that means, you know, you're an object that's thunk, when you are right up here, that peak height you have, okay? When you're at max height, your velocity at that position equals 0. Sometimes that can be your initial. Maybe you're starting at max height and you're falling down like that. Sometimes that could be your final. You're starting here and you're going to a peak, okay? But when you are at your maximum height, your vertical velocity, the velocity in the y direction, and we'll sometimes write this with a y if we're not talking about just being vertical, it is 0, okay? Meters per second, miles per hour, whatever, okay? It's 0. That's that point where you've bounced on a trampoline, you've gotten as high as you can get, you're just kind of floating there for a second, okay? In a moment, you're going to be falling back down, but at the moment, you're not moving, okay? Second thing you need to know is that when you are falling, and you're hitting, I'll put this in quotes, the ground, okay? When you're falling and hitting the ground, you have some velocity, okay? It is some number. It's often a negative number. This just makes sense because if you create some scenario where, you know, here's the ground and here's you drawn with the calligraphy pen, falling towards it. When you hit that ground, or whenever you're approaching this ground here, you have some negative velocity, assuming that the down direction is negative, okay? Whenever you hit that ground, yes, you are going to stop after you hit the ground, but if you all of a sudden, you know, opened up a little hole in the ground right here, you would continue to fall through it, and at exactly this location right here, you would still have some negative velocity. That's why you keep falling. Okay, so if you hit the ground, the very instant you hit the ground, you still have a velocity there. Okay, often it's negative simply because we often choose negative to be the down direction or the inward towards Earth direction there. Okay, so please remember that. Do not tell me that your final velocity when you hit the ground is 0. It's the easiest mistake to make. People do it all the time. It drives me nuts. Okay. Third thing you should know is if you're looking at something going up and down, gravity's a thing. It simply exists. You can't get rid of it, okay? And it's important to remember that on Earth, gravity, we use the letter G. If you're watching this from Walsh's class, you'll use AG in there, okay? Technically, it's a vector. Technically, I don't like to write that vector over gravity. But it is technically a vector. It is equal to 9.8 meters per second squared. Remember, it's an acceleration, meters per second. And oftentimes, just due to convention, we say that that downward or inward acting towards the Earth is the negative direction. So that'll be a negative value there, okay? That primarily comes up to your math classes, because in math, with your y and x-axis here, this is your positives, and these are your negatives. So normally left and down we can call negative, up and to the right we can traditionally call positive. If for whatever atrocious reason you're working in English units, that's negative 32 feet per second squared. Okay? And this is what we kind of covered in class today. Now, there are a few other neat things, tips and tricks regarding gravity, or not just gravity, but vertical motion that we can manipulate here. One of the neat tricks, and it's not really a neat trick, it just kind of makes sense, is that, we'll talk about this later on. Let's say here's the ground, and I have, I don't know, let's make it a soccer ball. I like soccer balls, right? I'm being artsy now. See the checker pattern? Maybe that's a golf ball, whatever. There's a ball on the ground. Somehow it goes up and then comes back down, okay? The amount of time it takes to go up and back down we'll call T. That's like the total flight time. Okay? You can kind of see that this curve here, while it really is just up and down, it is symmetrical. Okay? And in the absence of air resistance, this symmetry allows us to do a few different things here. At the very tippy top, when your when your velocity is 0, okay, you have traveled through half of the total distance. This is half of the flight time. Okay, so if it takes 2 seconds to do the whole arc, it only takes 1 second to go all the way to the top. And that's a very important thing there. Okay, so be aware of that. You could actually solve a problem by going to the top and then just multiplying the time by 2 to bring it back to the bottom. But you got to be careful with some other stuff, and you'll get used to that as we go through it. The other cool thing that you know about this problem is that your object starts here on the ground and it ends here on the ground. That means your displacement is 0. And technically speaking, oftentimes we'll use, like, just in general, displacement is delta x, but sometimes we will, and I know other teachers do and other books do this. Since we're going in the y direction, our y displacement is 0. Maybe we still traveled here a little bit in the x direction, and that's delta x, but delta y, the up-down, could be 0. Okay? The very last thing that we can make note of is, let's pretend that in the very beginning here, this ball was moving upward with a velocity, initially, of a positive 17 meters per second. Okay? Right at the very beginning here. Whenever it comes back down and it gets to this exact same height, so it started at the ground, it ends hitting the ground. When it gets to the ground and it impacts there, when the delta y is 0, the final velocity is the same amount, same magnitude, same size, 17, but this time it's in the negative direction. Okay? So if you start at a point, go up and come back down, not only do you know delta y is 0, if you know the initial, you also know the final. It's negative. And once again, don't forget trick number 3. This object's moving up and down. Gravity, 9.8 meters per second squared, negative direction. So in this case, we actually have like 1, 2, 3, 4 things just based off of a little picture of that problem. Okay? So there's a lot of cool stuff that you can do there with motion in a vertical direction. And these are important things just to remember. This isn't something that, you know, you have an equation for. It's not something that you need to work out mathematically. It's something that, you know, intuitively we can kind of think about it this way, and it'll give us a better idea of what we can pull out of a problem and what ungiven things, like what are things that have kind of hidden in the problem from you that you need to pull out. Okay? So that's just something to do there with intro to vertical motion. Okay? And we'll just place fin to that. Sir or Sirs, Hunter, glad you're following.